Okay, this lecture is over Chapter 5 of your textbook, which is talking about functions in the Python language. We have a couple of pages of topics. We'll talk about what a function is. We'll talk about functions that return void or no value. We're talking about how you create functions and their syntaxes. We'll talk about what local variables are. We'll talk about passing arguments into the functions. We'll talk about global variables and global constants. We will, as an example, do some stuff with Turtle Graphics and incorporate the Turtle Graphics calls into functions. We'll talk about functions that return values. We'll talk about how you write those and how you return those values. We'll talk a little bit about random numbers and the random module. We'll also talk a little bit about the math module, what those are, how you use them, and what functions might be in those modules. And then we'll talk about, they say, storing functions as modules. Basically, I would call that writing your own modules. And modules have, typically one or more functions in them. So, what is a function? Basically, a function is a group of Python statements that perform a specific task. We group those together into a function and we give that function a name. Down here, they're talking about divide and conquer approach. Basically, what they're talking about is if you modularize your program, that is, kind of break it down into specific tasks and then create functions that perform each of those tasks, that is referred to as modularization of your program. So here they're showing you on the left kind of what we've talked about and did in the beginning of the class, which is we just have a sequence of statements. I like to call this a straight line program. I think your textbook refers to it as just using sequence statements. Those are statements that execute top to bottom in the order that they are specified. Now then, what they're showing you on the right is that you can divide these statements or different tasks into functions and then call those functions, and they'll make your program, at least the main program, look a little shorter. Now, one thing I will tell you is if you've not programmed a lot using functions, you can go overboard. And they're kind of possibly going overboard here. It's kind of hard to tell because they don't tell you what statements they're doing. But you can make functions that call functions and make your main program only function calls. And like I said, you can get carried away and actually make the program more difficult to read than trying to make it easier to read, which is one of the advantages of modularizing your program. So here they're talking about benefits of modularizing your program. It says simpler code. The code's pretty much going to be the same, but I think this falls more under the divide and conquer, which is you can have a task that a function is going to perform, and you can spend your time just concentrating on that specific task, which will make it simpler to code, and also make it less likely that you're going to make a mistake because you're not thinking of the program as a whole. You're concentrating on one specific task. Another advantage is you can reuse the code. If you write a function that performs some task and then you're writing a different program that performs the same task, you can just take that function you've already written and call it. Either place the code in your program or, as we'll see, a little later in this chapter, create your own module and import that module that has that function you want to reuse. The better testing and debugging goes along with what I said about it being easier to write. It's also going to be easier to test and debug because you're just concentrating on one specific task per function. Typically, this will be faster development, especially if you're working as a member of a team. What you might do there, especially if you had a really large program, is you might design the functions and what they do, or specify the functions and what they do, and then you say, you go off and write these 5 functions, I'll go off and write these 4 different functions, another team member might get 6 functions, but basically you can divvy those out and code all those, and then we can bring them together and then call the functions as necessary from the main program. So that allows us to divide up the task of programming. Functions often have return values. If you have a function that does not need to return a value or any information back to the portion of the program that called it, then that's called a void function. That is nothing. So it returns nothing. As opposed to that, your function might return some type of value. And we'll see examples of this in a moment. And it can actually, I don't know if they say it right away, it can actually return multiple values if you need to. So no values, one value, multiple values are things that you might return from a function. So a moment ago I said you take a section of code or a block of code, group it together and give it a name. So that's the function name. You cannot use any predefined keywords, like you can't create a function called print or input, for example. It cannot contain spaces. The first character must be a letter or an underscore. All the other characters must be letters, numbers, or underscore. And it is case sensitive. That means uppercase and lowercase matters. So you might notice that these are basically the same rules for naming variables apply to naming functions within Python. The function should be descriptive. You shouldn't go off and name your functions function 1, function 2, function 3. You should say something like get input, calculate sum, that type of thing. As far as defining the function, you do that with the DEF keyword, which is just an abbreviation for define. So you say DEF space the name of the function, parentheses, colon, and then you have all the statements that make up that function. Now those parentheses right there, the parentheses have to be there. What they're showing here is a function that takes no arguments, but those set of parentheses and the things within that are referred to as the argument list. So if you need to pass values in, you do that through the argument list. Okay, so I just said all this. When you want to execute the code of a function, that's called calling the function. So for example, you might have a main program that's executing along, and then you call a function. When you do that, the flow of control of execution goes from your main program to the function. The function executes, and when the function is done executing, then the flow of control goes back to the location in your main program that you called that function. When you hit the end of the function or you return a value, that's known as the function return. Okay, so there is a main function that you can define, and that is the first function that is called when your program starts to execute. If you just have code there, that is an assumed main function. So, up to this point, we've maybe not written any code where we actually explicitly say this is our main program. But here they're talking about how you would do that. If you're defining code for a function, the lines in the block must be indented. So this is like any other Python statement. You have to indent it, and it has to be evenly indented. If you're using idle, when it sees the keyword def, it will start indenting for you, noting that you're defining a function. As other Python programs, I don't know if we specifically said this, but you've seen lots of examples of this. If you have blank lines in your code, they're simply ignored, and of course comments are ignored as well. So we talk about flowcharts. What we have here is a new symbol within the flowchart. We'll see a graphic here in a moment, but it is basically a rectangle, but you have like an extra vertical bar on the left and right show of it, or I'm sorry, right side and left side of it, to indicate that it is a function. We have these things called hierarchy charts, where we would go through, and just like we would draw a flow chart for the main program that would have a start and an end, we would have a separate section of the diagram, if you will, that shows where we call the function and where the function ends or where it returns. If we want to wait for a user to press enter, we can do that by calling the input function, just to have it set there and wait for any input from the user. So if you told the user to press enter, it would sit there and wait until they pressed enter, which would be a line of input. Here is a hierarchy chart that they've drawn. The main program is going to call get input, calculate gross pay, calculate overtime, calculate withholdings, calculate net pay. And a couple of these, for example, get input has a couple of things it needs to get. It needs to get the hours worked, and it needs to get the hourly rate. And to calculate withholdings, we need to calculate tax, and we need to calculate benefits. So this is showing you a hierarchy of function calls, basically what function calls what other functions. This is kind of an interesting thing that I've only seen in Python, but basically there's a pass keyword that's kind of a do nothing. So when you're going through laying out your subroutines, you can have your define statements, give the function a name, and you can simply say pass. So that is ignored by the interpreter, but the intention is, I don't want to think about the code to actually accomplish the task. I just want to think about the task I have to accomplish, and I will presumably come back later and fill in the Python code within each of these functions. We have this thing called scope of variables, and I like to think of it as where a variable can be seen. I think here in the middle they say it's where a variable can be accessed, which are, to me, the same thing. So you can have a local variable that only exists inside a function. Global variables exist for your entire program, which means any part of the program can access those global variables. As far as the local variables, that are local to a function, only code within that function can access that variable. So the scope is what part of the program can see or access a variable. The local variable has to be initialized before it is used. We can have variables of the same name, but that value for a function's local variable can only be seen within that function. So whatever value, let's say we have an x there, and x is 10 in this function, and x is 20 in this other function. It will only access the variable x within the function. So that's an okay thing to do. It might be kind of confusing if you're writing code or somebody's looking at your code, but it is an acceptable, valid thing to do. Now then, talked about arguments when I was talking about the function definition. Basically, we have arguments, which are pieces of data or values that we want to pass into our function, presumably to be processed or used for some type of calculation. So here we have a function called showDouble that takes a number, it multiplies that number by 2, and then it returns that value to the calling program. So at the top of this figure, in our main program, we set the value to 5, and then we call showDouble, passing that value 5 to it. So what happens is Python has different types of parameters, but right now they're showing positional parameters, which is whatever value was passed in the first argument, and in this case the only argument, kind of gets a new name in the function. So it's positional placeholder. So basically what you're saying, whatever I pass in as the argument to this function, I'm going to call number while I'm in the function. So I will use that word, that argument name, for the calculations in the function. Parameter values, these are when we call the program, that parameter and the argument both access the same value. The scope of that parameter, in the previous example, number, is only accessible within that function, or it's scoped to only be available in that function. So Perl's kind of weird in this aspect that we're getting ready to discuss. Most programming languages, you have pass by value or pass by reference. And what happens is Python starts out doing a pass by reference. So when we called in the main program, we have a variable value that points to or references a position in memory that has the value 5. When we go in, while we're in the showDouble function, there is a variable, it's a local variable, called number, and it references the same memory location as before. So it's basically one location in memory that in this case has two different names. We'll talk about in a moment what happens is if you change or that value in a function, and it's going to behave differently in Python than other programming languages like C++ if you've done any C++ programming. So again, arguments are passed by position, except when they're not, which we haven't talked about yet. So the first value matches up with the first argument, etc. So here they're just showing you that we call show sum with two values. We use the name num1 and num2 in the function. We calculate the result, which is the sum of those two values, and then we print that value out. So now we're going to talk about what happens if you make a change to the parameters. What happens is, as I said, they're going to switch from change by reference or pass by reference to pass by value, so that you don't alter the value in the main program. So what happens is, if we start out and we have a value 99 and we call the function arg is going to point to the 99. Now if we set arg to 0 and then print it out, it's going to print 0 because we just changed the value of that parameter. But what's actually going to happen is Python's going to realize that you're changing that parameter, and what it's going to do is it's going to change it from a reference from the original memory location, in this case value, and it's going to create a new memory location, put the changed value in that memory location, and then make the parameter, in this case arg, a reference to that new value. So normally in other programming languages, when you pass things by reference and you change them, it changes it everywhere because there's not this changing of memory location referencing. But in this case, in Python, sometimes that can be problematic and be hard to debug. So Python evidently solved this problem by switching it from they start out call by reference or pass by reference to conserve memory, but if you really start changing it, then it's going to create a memory location for it to make it less likely that you make a mistake in your programming. So like I said, Python's the only language I know that handles it this way. Now then, you can actually give your functions arguments names, and what happens is you can say parameter equals value, and then what happens is the positional part goes away because you're referencing them by name. You can require all arguments in a function to be passed as keyword arguments. The way you do that is you put an asterisk at the beginning of your parameters list and a comma, and then put all of your parameters, and basically the function will only work if you use keyword arguments for all the arguments. As we'll see in a moment, you can put that asterisk other places, and it makes the arguments before that asterisk positional, and then the ones after keyword based, and they can keyword arguments can be in any order. So here what they're doing is, because you have that star comma at the beginning of the parameter list, it's saying that this function show sum will take keyword only parameters. So an example of this would be this. I'm actually going to have to say A equals some value, B equals some value, C equals some value, and D equals some value. The one below will not work correctly because the first argument does not have a keyword name in front of it. Here they're showing you that A and B are positional, so the first value will go into A, the second value will go into B, and then C and D have to be keyword parameters. You can force Python to only accept positional parameters, and you do that with the /. So all the parameters that appear before the / will be positional only parameters. So in this case, since the slash is at the very end, A, B, C, and D are positional parameters. And you cannot use keyword arguments, which means if you at the beginning put A equal 10, it's not going to like that, and it will give you an error. So this is showing you just that, if you have 4 values, the function will work correctly. If you try to use any keyword values, the function will not work. Just like the asterisk, the slash can appear in different places. So in this case, the first 2 arguments, A and B, are positional only, but C and D can either be positional or keyword arguments. So this is just another example that A and B are positional, C and D are keywords. Sometimes you have default values, and you can set that in the argument list. So in this case, the first value is price. The second value is the tax rate. But if we don't pass a second value, or we pass in a keyword value, tax rate, and give it a value, that's the value that the function is going to use. But if that is omitted, it's going to use a tax rate of, in this case, 7%, which would be the 0.07 that is shown. Here it is calling it with the default, and the reason is calling it with the default is because we pass in a price of 100, but we do not pass in a tax rate. Here, if for some reason we needed to use an 8% tax rate, then we would pass in the second argument, the 0.08, which would be a 8% tax rate. Here we're setting a default price of 10, and then calculating it. So instead of the tax rate being a default value, they're trying to use the price, but it's going to be invalid because it is following a keyword that has a default value. So all the things that do not have to have default values have to appear first in the argument list. Then after that, we can have keyword arguments to override, if you will, the default value. So here we actually have 2 things that are default. So if we just called show tax, it's going to multiply 10 by 0.07 and say, okay, the tax on this item is 70 cents. I think I already mentioned this. Global variables have the scope of the entire Python program that you're running. If you just use a value in the main program, it is going to be global. If you are going to use it in a function and assign a value to it, you're going to have to specify the keyword global space and then the name of the variable that you want to be global. Global variables are considered a bad thing because you can change them anywhere because they're in scope for the full program. The other bad thing is if you have a function and you use a global variable, and then later you say, hey, I have this function I want to reuse, and you move it over into another program file. If you don't know to define that global variable before you attempt to use it, you're either going to get an error, or possibly if you happen to use the same name variable, maybe it will have a value or a behavior different than what you had in your main programs. So for those reasons, it's typically thought that global variables are a bad thing. Now, global constants are things that are values such as the value of pi, for example, that we want to be available to the scope of the entire program. However, it is not going to change in value. We talked about void functions. Void functions are a group of Python statements that do perform a specific task. However, they do not need to return any information to the calling program. A value returning function performs some task, often a calculation, and then it has a value or values that it would like to return to the calling program. Here they're talking about library functions. Things in Python standard library are just available to you when you start writing a Python program. So print, input, and range are three examples that we've seen over and over again that are actually functions that are part of the Perl language, and we call them. Here they mention that they're black boxes. We know how to call them. We know what they will return, but we have no idea what code makes up those functions. There are other library functions that come with Python that are not available unless you use the import function. So standard library functions, you can just call the function, but for other modules that have library functions, you're going to have to import them. So by the time you're hearing this lecture, we probably will have talked about importing math would be one of the modules we imported. Possibly I've mentioned the time library. So those come with Python or the Python installation, but to actually use them you have to say import at the top of your program. Here they're going back and reiterating that the library functions are written by somebody else, and we don't know how they work, we don't know what code is there, but we really don't need to as long as we know they're going to work. So you call the print function and you get output like you would expect. You have no idea how many lines of code or what the code is or anything like that for the actual definition of the print function. Another thing that we often use is random numbers. So they're using this as the first example to a library that is not part of the Python standard library. And the way we call these functions is we say module name period the name of the function within that module that we would like to call. So there is a function called ranInt that generates a random integer, and here they're talking about you can experiment with this if you would like within interactive mode, but basically when called like this with two arguments, it's going to, from the random library, call the function ranInt and return an integer between 1 and 100. And whatever that function generates is going to be the return value, and then that return value in this case is going to be assigned to a variable called number. And then in the case below, we're saying just print that random number in the range of 1 to 10. Rand range is like the range function, but it will return randomly selected integers from whatever the resulting sequence would be, like the range function. There is a random function that returns a value between 0 and 1, and if that's not exactly what you need, you can multiply and or shift that. So like if you needed numbers in the range 10 to 20, you could generate a random number between 1 and 10 and then add 10 to it, and that will shift the range. Uniform allows you to return a random floating point number, but allows you to specify the range. Here they're talking about seed values. Random number generators are seeded. If you always seed the random number generator with the same seed, then your sequence of quote random numbers is going to be exactly the same. So what happens is when Python, when you initialize the random number generator, it's going to look at the current time, the system time for the machine you're on, and use that as a seed to the random number generator. So every time you run your program, it'll be a different time. It will get a different seed, which will result in a different sequence of generated random numbers. If you want to seed it with your own value, down at the bottom you can call random.seed and pass a seed value into it. To write a function of your own that returns a value, somewhere in your program you're going to have return followed by a statement or a calculation that calculates or specifies the return value. So here we're defining a function sum. It takes two numbers, it adds those together, puts them in a result, and then there at the bottom we have return result. So whatever the numeric value is of that addition will be what is returned to the main program. And like we saw before, you would then either use that value in a print statement, or you might assign it to a variable. If you're performing the same mathematical calculation over and over again, you might group that into a function and then just call the function to have it perform the calculation and return the value or values to the calling program. IPO charts. IPO stands for input, process, output. They use these for specifying what input a function takes, what function or what processing the function does, and then any output that the function generates or returns. Prior to this, this is very similar to pre and post conditions. So preconditions of a function are things that are true when the function starts, including information about the arguments, and then the post conditions are what does the function return, what does it change as a result of running the function. A lot of times when you write these, you will put these at the beginning of your subroutine definition. So here's an example of IPO charts. So we have a function get regular price. There's no input to this. It actually prompts the users for the regular price of the item, and then the output is the item's regular price. Pretty simple thing. Don't know if you really need a function for that. As far as discount, the input is going to be the regular price. It's going to multiply that by a global discount variable named discount underscore percentage, and then what it's going to return or output is the item's discount. So we've mainly been talking about returning numbers, that is integers and or floating point numbers, but functions can return strings as well. So here's a function called getName. When we call it, it's going to ask a person for their name, and then it's going to return that name to the calling program, that is wherever get underscore name was called from. You can also return Boolean values. Again, Boolean values are either true or false. In Python, they must be written as shown here, true with a capital T or false with a capital F. A lot of times these are used related to input validation. As I've alluded to several times, a function can return multiple values. The way you do that is have the return keyword, but then have a comma separated list of values that you want to return. If you're doing this and you're assigning those values to variables, you need to have the same number of values separated by commas on the left hand side of the assignment statement. So here's an example that shows you calling a function and then returning a result, but it introduces a new special value called none, which means there is no value. So in this case, what they're trying to do is you're trying to divide num1 by num2, and you should know that division by 0, unless you're using complex numbers, is undefined. So what they're trying to do is catch an attempt to divide by 0 and set that to the none value. Now, most other programming languages call this null. So if you've talked about null values in other languages, the none value in Python is the same concept. We talked about the random library function, or I'm sorry, the random library. They talk about the math module, which is part of the standard library for performing some calculations. To use it, you're going to have to say import math prior to attempting to use any function from that library. Here's some examples, arc cosine, arc sine, arc tangent, ceiling, etc., all the way down to tangent of x. So these are things that you might do in math that are more complex than like addition, subtraction, multiplication, division, the things that are built into the Python language. The other thing it does is this module defines variables pi and e. So instead of having to define your own constant or putting 3.14159 for example for pi in a calculation, you can call math.pi. So the area of a circle is 2 pi r, pi r squared. So math.pi times radius raised to the second pi is the way you could use, for example, the predefined value of pi. Modularization, we've kind of already mentioned that. Breaking your program into pieces, which means putting some of it in functions, makes it easier to understand, easier to write, easier to test. A module oftentimes is used somewhat interchangeably with library. A module is a file that contains Python code. It contains function definitions. It says but does not call those functions. Well, it might call them internally, but what they mean is you shouldn't be calling other modules that you've written or functions that are in other modules. When you create a library file, that file has a name that and the name should end in .py, and then to access things you put in that module file, you would use the import statement. So for example, with the math module, somebody else wrote that and sent it to us, or it came as part of the Python installation. These are talking about modules that you would write your self. Here they're kind of talking about user experience. Often what happens is you have a menu driven program, which means you present the user with a menu like press 1 if you want to add numbers, press 2 if you want to multiply numbers, and they select things from that desired list of operations, and then it calls a corresponding function, and it typically repeats that until the user gives a sentinel value or somehow indicates, maybe choosing a menu option, that they are ready to quit the program. You can create modules that can either run alone by themselves or be imported into another program. I would say the second is the more common thing to do. Here they're talking about program 1 defines several functions that you want to use in program B. You can import program A into program B, but you do not want it to execute programs A main function because program B presumably has its own main function. So what you can do is use a special variable underscore underscore name underscore underscore, actually it's 3 underscores I think, underscore name, and it creates it and gives it the name of the file. So what you can do is you can check the name of the file that you load in and decide based on that value whether or not to execute the main program. So that's the conditional execution of main. So here you would say if name equals equals main, then call the main, for example, to execute the main program from the particular library. Now then, as often is the case, we end up with some Turtle Graphics stuff related to topics. So we're going to do modularization of code related to Turtle Graphics. So here what they're doing is they're taking the statements that you would often do to draw a square, and instead of every time you want to draw a square repeating very similar section of code over and over again, is they're defining a function called square. It's giving an x and y coordinate of where to start. It's giving you a width and allowing you to specify a color of that square. So that's the definition of the square function that they've written, again using the Turtle Graphics module. So what they do here is, the first line of code at position 100, 0 for a size of 50 creates a red square. The second line of code creates that blue square, and the third line of code creates the green square that's shown. Here they're doing the same thing with a circle function. And then they have examples of where they're calling it to draw different size, different location, different color circles as shown on the screen. Here they're defining the code to draw a line. You have a start X and Y position, an end X and Y position for the other end of the line, and then you specify what color of line you would like drawn. And here they're defining some information about a triangle, and then they're calling the line function to draw the three sides of the triangle, and it just so happens that they specified each side of the triangle to be a different color. So that finishes up chapter 5, and typically don't read the summary to you, so I'll leave this here a second so that you can look through. These are the things that we've talked about and or that you should have read in your textbook and understand. And the second page of that is these topics. So that finishes up the lecture for chapter 5.